Okay, we're going to do horizontal example problem number 2. In this case, we have a car ridden by a ghost rider, or we can just say the riders of the car bailed out of the car, the brakes went out, and the car was flying towards the cliff, so they jumped out safely and rolled like a stuntman. So that the car goes over the cliff with no passengers in it, completely safe, right? And now what do we know? In this case, we know the height of the cliff, and we know how far away from the base of the cliff the car lands, right? It's probably going to land head first, and then crunch to the ground, okay? Safely, with no one in it. Of course, we wouldn't want to injure anyone in our physics problems. So, how do we set this up? Again, when I go to my givens, XY table, every time. Now, just for completeness sake, I'm going to give my AY and my AX every time. As a reminder that it accelerates vertically according to the rate of gravity, and the X acceleration is 0. Now, I am given, in this case, my delta X, and I am given my delta Y. I will call my ground my Y of 0 so that my falling displacement is negative. Okay, what do I want to find out? I want to find out what was the initial X velocity of the car. Now, it's a cliff, it's flat, so what can I assume from that? I can assume that it has no initial Y velocity. None of its velocity is in the Y direction to begin with. So this is 0. And once again, my time in the air will connect my problem. So let's work backwards. So I'll do my X in green. So I know that my X velocity is equal to my X change in position over delta T. I have my X position. I don't have delta T. So I need to find a way to figure out how long the car was in the air. Then I can find my X velocity, right? Check here, no check here. So let's go back to the Y direction and take a look. I know my initial Y velocity is 0, delta Y is negative 19, A sub Y is negative 9.8. Can I find delta T? Yes, I can go back to the second equation again. So in this case, delta Y is going to be V naught Y delta T plus 1/2 A sub Y delta T squared. Once again, this is 0, which you'll see makes these problems much easier. So delta Y is 1/2 AY delta T squared. You'll see soon why we do horizontal problems first. They become a little simpler than angle problems, where this is not 0 anymore. But for now, multiply by 2, divide by AY, and square root everything. I get 2 delta Y over A sub Y square root equals my delta T. So 2 times negative 19. I was doing 9.8 right away. 19 meters over 9.8 meters per second squared equals delta T. So let's plug it in, calc it out. My delta T is, so 2 times 19 by 9.8 square root 1.969 seconds. Whoop, that goes into my given now. Now, I can use that to solve for my initial X velocity. So V naught X equals delta X is 13 meters, time is 1.969 seconds, meters per second, which is good. So Vx equals 6. Let's see, hold on a sec. I had it written down, but I couldn't see it. 6.6. 0.02 meters per second. And that is my final answer. So again, I used the Y information to find time, use the time to find X information, and that is horizontal problem number 2.